is calculated indirectly by using Born-Haber cycle method. The Born-Haber cycle explains the energy changes that takes place whether in a single step directly or in several steps indirectly is remains constant, does not changes. Right. So here the formation of 1 mole of ionic solid crystal in a single step we can represent a solid metal is combined with half mole of gaseous non-metal molecule. It forms a solid crystal lattice 1 mole. Right. Doing that, the released energy is we call them as enthalpy of formation. Right. Then the same 1 mole of solid crystal lattice is formed in 5 steps, in several steps indirectly. That is, at first step, the solid metal atom is to be converted into gaseous metal atom. Then the required energy we call them as sublimation energy. Right. Then the gaseous metal atom, it loses n number of electrons and to be converted into gaseous stable metal ion. For that, the required energy we call them as ionization energy. Then the non-metal gaseous molecule is to be converted into non-metal gaseous atoms. For that, the required energy is called bond dissociation energy. We need only 1 mole of gaseous metal non-metal atom. For that, you need only half of the gaseous molecule. That's why you get half of the BDE, right? Then the gaseous non-metal atom, it gains a number of electrons and becomes into a stable gaseous non-metal anion. Then during that, the released energy is called as electron affinity. Electron affinity, right? Then now a stable metal cation is combined with a stable non-metal anion. Then you get 1 mole of solid crystal lattice. During that, the released energy is called lattice energy, right? Now, so the energy changes that take place in a single step, that is denoted by, that is enthalpy of formation, that is denoted by letter Q. So we can just represent as enthalpy, that is delta H1, and this is all the 5 steps that is represented as delta H2, and H1 is equal to delta H2. What is delta H2? Delta H2 is nothing but the sum of all these values, that is sublimation energy and ionization energy, and then body dissociation energy, these are all positive, and that is electron affinity, and then lattice energy, these are negative, right? So delta H1 is equal to delta H2. That means both the steps equal means the both the steps, how much amount of energy that is released here, the same amount of energy that is released here also. That means the energy changes takes place whether the reactions take place in a single step or in several steps, this remains constant. So then delta H1 is denoted by the symbol Q. So Q is equal to what? Delta H2. What is delta H2? This is all you have to represent. Q is equal to plus S plus I plus B, half of the BDE plus half of the BDE and minus A and minus Q. Then you want to find out U. What is that lattice energy? Then U is equal to what? U is equal to, it is plus S plus I and the plus half of BDE and minus electron EA and minus Q, that term, right? So we will get lattice energy, right? So this is the method used to calculate the lattice energy of a ionic compound, right? Then, what are the factors influencing lattice energy? So from this concept, the previous year theory questions are there, my dear students. What is that? Here, the lattice energy influenced by the first factor is the size of the metal atom or non-metal atom. The size of metal atom or non-metal atom. Size of metal and non-metal atom. Right. That means, so mainly you have to consider it here, the size of the metal atom. The size of the metal atom must be smaller. And the size of the non-metal atom also must be smaller. Right? Okay. So for example, that means here lattice energy is inversely proportional to radius of cation and radius of anion. You know, the cation is formed by metal atom whose size must be smaller, anion is formed by non-metal atom whose size is also smaller, right? That is inversely proportional. Inversely proportional. This is just to keep this point in our mind. Keep this one. Keep in our mind. Then you can get in the concept, right? So now I'll give some examples. What type of person you can come across the previous year? That is, you can take it here. For example, there is lithium chloride, sodium chloride, potassium chloride, rubidium chloride, and cesium chloride. So they will give which among the following ionic compounds having high lattice energy or low lattice energy or increasing order of lattice energy or decreasing order of lattice energy. How to answer it? Our concept is there, right? So there is here anion is same, chlorine only. Cation is different. What is that? Lattice energy is inversely proportional to radius of that is a metal atom, right? So here this is R, that is if it is smaller, then lattice energy is more. That means the cation is smaller in size, more amount of lattice energy released. Now tell me answer. So lithium chloride is a smaller size, so that's why the lattice energy of lithium chloride is more and cesium chloride is very less. Right. Next, or maybe one more example. This also relates to process. You can get it here. For example, take it here a sodium fluoride and a sodium chloride and so sodium bromide and sodium iodide. Yeah. Here the cation is same sodium, anion is different. There is fluorine, chlorine, bromine, iodine, right? So here, what are the condition that is the factor that is inversely proportional to reduce of anion. So which is fluorine to iodine, that is larger size. Iodine is larger size. FN is smaller in size. So that's why during the formation of NAF, large amount of lattice energy is released. That's it. Right? Don't need to buy order. Concept is important. That you keep in your mind. Next, another very important factor that is lattice energy is also influenced by the charge on the ion. Charge on what? Ion. Charge on ion. Charge on ion. Charge on ion. The charge on ion is more amount of lattice energy releases. Right? That means lattice energy is directly proportional to charge on ion. For example, it is a cation, it is a Z plus, it is an anion, Z minus. What is Z? There is a charge on cation, this is a charge on anion. Right? This is directly proportional. You just multiply it, you get the value is more and lattice energy also more. Right? That is. So for example, take it. This is a previous year question. This is you can you are learning here only what type of questions are appearing also. Right? So for example, take it here. NaCl, MgCl2, PaLCl3. Yeah. Which one? Which one would having more lattice energy? Okay, you didn't get all these type of questions in previous, but the previous questions you get, but in the reference of the books, you didn't get these type of concepts. All right? Yeah. Very nice. Here, so AlCl3 have more lattice energy. Why? Because here the charge in here 1 to 1, you get 1. Then here charge is plus 2 and is minus 2. This is 6. So more amount of charge is there, then more amount of lattice energy releases. Yeah. That's right. That's right. Yeah. Got it? So these are the two factors. Now, I'll give one small thing. There is lattice energy is directly proportional to what? The charge on cation and anion, and inversely proportional to radius of cation and radius of anion. So one more formula is given by a scientist who is performing. According to him, lattice energy is calculated by using the formula N0 into Z plus into Z minus by, and here V square upon R square into D. What is N0? N0 is nothing but Avogadro number of molecules, Avogadro number of ions, Avogadro number. Then Z plus is charge on cation, Z minus is charge on anion. E is nothing but electronic charge, not of type. Charge of how many number of electrons that is there. Electronic charge. R is the radius that is of cation and anion. And D is dielectric constant of that particular ionic compound, right? Dielectric constant, right? Yes. So, but here, what you want, you just want this one is important because this higher is the advanced level we are just dealing for that one. But here it is enough for your NEET examination, JEE examination. Fine, got it? Okay, comment. Read fast. Yeah, next. So this is about the energy changes during the formation of ionic compound. So we did about what is ionic bond and what are the factors favorable for ionic bond formation and formation of ionic bond and what are the molecular, there is a formula, how to write a formula of ionic compound and then energy changes in ionic bond. Next now, finally, we're going to do about properties of ionic compounds. Properties of ionic compounds. Properties of ionic compounds. Yeah, one by one. First one, ionic compounds, first physical state. Students, generally, all ionic compounds are existed in solid state. These are crystalline solids. Solid state. Why? Because in ionic compounds, what are their ions are there? So opposite the other ions are close compact carrying, right? So because of these two ions, strong electrostatic attractive forces are there. Because of strong attractive forces, the two ions are come closely back into that. Because of close packed element, the substance is existed as solid. Next, second one, solubility. Before that, we'll do density. I will arrange all the points are orderly. Density of ionic compounds. So ionic compounds, ions, right? These are close compact arrangement. So that's why more number of ions are accommodated in less space. That's why they have high density. That is, density is very high. Next one. Another one is brittlity. We can call as before that we can call hardness and brittlity. We can call it brittlity. What is brittlity means? I'll tell you. Ionic compounds are very hard nature. Why? Because they are exhibiting crystalline solids, not amorphous solids. Crystalline solids means why? Because all ions are close compactly arranged because of strong attractive forces. Because of that, more number of ions are accumulated in the lesser space. In a particular unit cell, in the solid state also, a particular unit cell, more number of ions are accumulated. That's why here they are very hard, right? So ionic compounds are very hard, and even though they are very hard, you can easily break it in the form of pieces. It is called brittle nature, break into pieces. You know, for example, take it a simple example: rock salt. That is NaCl, salt, right? So not as a salt powder, that is rock salt, crystals are there, crystals. You just take it and you can break it, right? That is the thing. That is the brittle nature. Brittlity, right? Next one. Melting point and boiling point. Melting point and boiling point. They have high density. They're very hard. High density, very hard. That's why to convert from one state to other state, from solid to liquid, liquid to vapor, you have to apply, you have to supply very high temperature. That means they have very high melting point and boiling point. Why? Because ionic compounds are existed in crystalline solids. In this, the ions opposite each other, ions are close compactly arranged because of strong electrostatic attractive forces. Because between the ions, electrostatic attractive forces are stronger. To convert from one state to other state, we have to supply very high temperature. Then only they overcome the attractive forces and then they convert from solid to liquid, liquid to vapor. Right? Next one. Solubility. Generally, ionic compounds are soluble in polar solvents. Ionic compounds are soluble in polar solvents like water, liquid ammonia, like this, right? So in water, H plus OH minus, polarity is there, two poles are there, positive pole H plus, negative pole OH minus. This is called what? Polar solvent. Polar solvents have polarity. What is polarity? Have two poles, positive pole and negative pole, right? So what is H plus in the OH minus, two poles are there. And NH also there is H plus and H2 minus, right? Like this. That means ionic compounds are soluble in polar solvents. Why? Because ionic compounds itself are positive and negative poles on the right. So for example, like sodium chloride water, and your present is Cl minus, right? So if the sodium chloride is get dissolved in water, it is released in water. What happens is, so the negative part of the water molecules accumulate around in the positively charged cation, and the positive part of water molecules are accumulate around the negatively charged anion. Why? Because it is a negative, it is a positive. It is a positive, it is a negative. Got it? So this type of accumulation of water molecules around the cation and anion of ionic solid is called what? Solubility. This is called dissolving. Solubility is nothing but what? Accumulation of what? A particular solvent. It may be water, it may be any solvent. This just get accumulated around the molecule that is cation and anion of the ionic compound is called what? Solubility. Then the compound is called dissolved, soluble. Okay, yes, right. So that means here ionic compounds are positive, negative charges are there. So that's why they are soluble in polar solvents, because like dissolves like. Like dissolves like. So I am ionic, I am soluble in ionic solvent only, like that. That's simple concept. In the biology also, like begets like. That is the central dogma of genetics, right? Like begets like. Every organism tend to produce its own offsprings, right? Okay, so a neem plant can give birth to another neem tree, right? A neem seed. Okay, so dog species, like a dog parent can give birth to a dog prosody, right? Okay, from dog you didn't get a rat, right? That is every like begets like this also like let's say I am a ionic. I am soluble in ionic solvent. It's polar solvent like this. Yeah. Next one. Another one is conductance. Conductance. So ionic compounds act as good conductors of heated electricity. Good conductors of heated electricity, right? Why? But here one important thing. Ionic compounds act as a good conductors of heat and electricity. Good conductors of heat and electricity. In which state? In which state? There is in aqueous solution state and in molten state. Molten state, aqueous solution state and in molten state. There is but these are bad conductors of heat and electricity in solid state. Very important. In solid state, these are bad conductors. Why? Because in solid state, this previous person. In solid state, ionic compounds are why bad conductors? That is, they don't carry electric current from one to other place. So the electricity is due to either mobility of ions or mobility of electrons. What is electrical flow of charge? Which charge? Flow of electrons. Electrons are negative charge. Flow of negative charge is called electricity. Or mobility of flow of ions. Mobility of ions. Okay. So ions can carry electric current from one to other place, right? So that's why here, if ionic compounds are get dissolved in water, they are soluble and they form cations and anions. So these cations and anions are mobile, freely mobile. They move from one to other. Wherever they move from one to other place, they can carry electric current from other place, right? And in molten state means what? You have to heat it. The ionic solid is heated, then the solid is become a liquid. The liquid, what are they? Ions are there, right? So these ions can carry electric current from other place. Mobility of ions is responsible for electric current, right? But in solid state, they are bad conductors. Why? Because very important. The reason is in solid state, the ions are in a fixed position, rigid position. They are not in movable position. They are fixed position. That's why they won't carry electrons. Next one. The chemical reactions. The chemical reactions between two ionic compounds is very fast, instantaneous, very fast. Within fraction of second. Within fraction of second is over. Why? Because, for example, for example, there is sodium chloride. Sodium chloride is reacting with silver nitrate. You take it sodium chloride aqueous solution in a 5 ml of sodium chloride aqueous solution in a test tube, and in another test tube you take it 5 ml of silver nitrate in another test tube aqueous solution, right? Then here 5 ml here, right? So both of these, you just take it 2 ml of NaCl, you just add to the aqueous AgNO3 solution. Within fraction of second, what you get, the right precipitate of silver chloride is formed. Silver Ag plus NO3 minus Na plus Cl minus, these two are combined, and then NaNO3 is formed, right? So AgCl and NaNO3 is formed. AgCl is formed as a precipitate. It is the right precipitate, which is formed within fraction of second. Within fraction of second. I'm not saying meter. That is that much very fast, right? Okay. Why? Because in ionic compounds already free ions are present. Ions are free. Immediately they combine. Okay, you come with you, you come with me, like that. Immediately the reaction is happening, right? Why? Because there is a reason. But in covalent compounds, covalent bonds are there. Okay, you have to break the covalent bonds, old bonds, and you have to make the new bonds. Here, in ionic compounds, there is no bond breaking, there is no new bond making. That's why only ions are existed, which are really existed. Okay, here Na plus Cl minus is there, here Ag plus NO3 minus is there. So they both are coming immediately. We get what? Product with the fraction of second product. That means the reaction is over with the fraction of second. That is called what? Chemical reactions take place very fast, instantaneous. Right? Yeah.
Molten state.
Molten state means you just heat it. That is, the ionic compound is heated, this gets melted into liquid. The solid is become the liquid state. This is aqueous solution state. Aqueous solution means the ionic compounds get dissolved in water. When it gets dissolved in water, in water it is ionized, right? Na plus and Cl minus. That means when any ionic compound which is dissolved in water, it ionizes to form its respective cations and anions. So these ions are really mobile, they're moving. Whether their mobility of these ions can carry electric current from one to other place. Right? Our following. Yeah. Next, another one is isomerism. What is isomerism? Isomerism means ionic compounds does not exist isomerism. Yeah. Why? Because the ionic compounds, what are the ions are there? Ionic compounds, these ions are arranged in a three-dimensional crystal lattice, right? Three-dimensionally. Okay, all these ions, Na plus N, Na plus N, is all arranged in three-dimensionally. That's why They are not arranged in a particular direction. They are arranged in the entire crystal in all the spaces occupied, right? They are not arranged in a particular direction. That's why they are non-directional property. Non-directional. If you take it a covalent compounds, the covalent bonds are arranged in a particular direction to give particular geometrical shape of the molecule, right? But here, ionic compounds, the ions are arranged in all the spaces available three-dimensionally, right? Okay, that's why they are non-directional property. So ionic compounds are non-directional. That means the ions are not arranged in a particular direction. They are non-directional property. Because of that, they didn't exhibit isomerism. Got it? So these are the properties of ionic compounds. Right? Got it? Next one. So this is about entire concept related to ionic compounds now. Next now, cooperate. Next one. Till now we did about that is ionic compound, ionic bond. Next now we are going to do about the next bond, that is covalent bond. Covalent bond. What is covalent bond? The bond formed between the two atoms by mutual sharing of electron pair. For example, if you take it atom A, it contribute one electron. Atom B, it also contribute one electron. It provide one, it provide one. It give one electron, it also give one electron. And forms one electron pair. Here this electron pair is shared by atom A and also atom B. This electron pair belongs to this A also and also B also. Then the bond formed between these two is called covalent bond. Covalent bond is denoted by a solid line or a dash with the two atoms. So then the molecule we call as AB molecule. In AB molecule, wherever the solid line is there, that indicates between me and you, the covalent bond is present. That's the meaning, right? So means here, so covalent bond means here this equal contribution of electrons. If you give one electron, it give one electron. If you give two, it give two like that. So equal contribution of electrons and equal sharing of the electrons. Then the bond formed between these two is called covalent bond. That means covalent bond is defined as the bond formed between two atoms by equal contribution of electrons and equal sharing of electrons is called covalent bond, right? So covalent bond is of different types now. Now we're going to discuss about types of covalent bond. So it is based on number of bonds formed. Based on number of bonds formed between two atoms. How many number of bonds are formed? Based on number of bonds formed, covalent bond is of different types. First one is, it is called single covalent bond or simply called single bond. That means, for example, if you take it H2 molecule, okay, H2 molecule here, so hydrogen contribute one, other hydrogen also contribute one, and forms one electron pair. One electron pair. This electron pair is shared by this hydrogen atom. It gets 1s2, helium configuration is stable, and this electron is shared by this other hydrogen atom also. This also get 2 electrons, that is a helium configuration. Now, so both are reaches a stable configuration. Then between these two hydrogen atoms, one covalent bond is formed by the sharing of one electron pair. Then the molecule we call as H2 molecule. With the H2 molecule between two hydrogen atoms, one covalent bond is formed by the sharing of one electron pair. That is called single covalent bond or simply called single bond. That is the covalent bond formed by the sharing of one electron pair between the two atoms is called one electron pair. Okay. By the sharing of one electron pair, the bond formed is called single covalent bond or simply called single bond. Right? By the sharing of one electron pair. Between the two atoms, between the two atoms, simply got to say, between the two atoms, if one electron pair is shared, then the bond form is called single bond. Right? Next, another one is double covalent bond or simply called double bond. For example, take it oxygen atom. So oxygen having how many valence electrons? 6 valence electrons. This belongs to 16 group valence. We have 6 valence electrons. That is called 1s2, 2s2, 2p4. 2s2, 2p4 means what? 2s electrons and 4 p electrons. 4 plus 2, 1, 6. Right. Yeah. So then another oxygen atom also. So it also has 6 valence electrons. Now this oxygen, you need how many electrons to get stability? 2 electrons. 6 plus 2, 8. Octet group, right? It is unstable, right? It is also 6 electrons. It is also unstable, right? There is crying. Crying means it is unhappy. It is unhappy, it's unstable. Then it gets stable. We have 8 electrons. Then it is going. So oxygen, I have 6 electrons. You give for me 2 electrons like that. Then it is also saying, no, I actually I am supposed to want to ask to you. I also need 2 electrons. You give for me like that. It is also saying responding. Then so both have an agreement. Okay. You do one thing. You give 2. I also give 2. Then we'll share both the 2 pairs of electrons. Then both will get reaches 8 electrons. Right? Then what you get here? That means this it provides one oxygen atom provides 2 electrons. Other oxygen atom also provides 2 electrons and forms 2 electron pairs. Right? These 2 electron pairs are shared by both oxygen atoms. So these are shared by this. Now we have 8 electrons. See, 1, 2, 3, 4, 5, 6, 7, 8. And these 2 pairs of electrons shared by this one also. But the sharing of 2 pairs of electrons, look here. With the sharing of this side, you get one covalent bond. With the sharing of this electron pair, you get another covalent bond, and this one bond pairs. Right? Now, with the 2 atoms, 2 covalent bonds are what? With the sharing of 2 electron pairs, then the bond is called as double bond. If 2 electron pairs are shared, the bond form is called double bond. That's it. Yeah. Next one. Triple covalent bond. For example, nitrogen. So nitrogen belongs to 15 group element. It have 5 valence electrons, right? Then other nitrogen also take it. It also have 5 valence electrons. So it needs how many electrons? 3 electrons. It is asking, I have 5. I need 3 electrons. You do for me. I'm unstable. I need to get stability. Then it is also saying the same thing I'm also experiencing. You do work for me. Then both are agreement. Then one event. So this one nitrogen atom provides 3 electrons. Another nitrogen atom also contributes 3 electrons. Both are equally contributing, right? Then it was 3 electron pairs. 1 pair, 2 pair, 3 pairs. 3 electron pairs are formed, right? This 3 electron pairs shared by both the nitrogen atoms. This also and this also. Now both reaches 8 electrons. Then with the 2 nitrogen atoms, by the sharing of 3 electron pairs, 3 covalent bonds are formed, right? Then this is called triple covalent bond, right? Okay, right, students. So this is the one types of classification of covalent bond. So some more classification types are there. So thanks. So next class we will continue the following. Fine.